something that we all care about and something that affects all of us. I'm president of the Lower Keys League of Women Voters. It is an organization that is nationwide, statewide, and has local affiliates. The local affiliate we have here meets once a month. It's a nonpartisan organization. We deal with all of the issues, primarily voting rights, but here locally, we've been dealing with gun safety issues. And as you signed in at the desk, you probably saw we have gun locks, and we've been putting them in a lot of different places around town. And it has been something that almost everyone agrees on is gun safety, regardless of what your views are on guns. But anyway, get the literature from each of these organizations. Each of the organizations will be able to speak for a few minutes. And we do value everybody that participated, everyone that is here tonight. I'm really gratified that we have a good crowd. And I will hand it over to whoever's going to speak next from Reef Relief or Last Stand or any of the other people, the City of Key West.
Okay, good.
If they want to speak. Here we go.
It's us, Allison. Hi, guys. My name is Dora DiMaria, and I'm the Assistant Executive Director of Reef Relief. If you are not familiar with us, we've been around for almost 40 years, and we focus on coral reef conservation through education and outreach. We've taught over 14,700 students since September alone of the school year, and that's within 44 different states and over 18 different countries. Besides that, we do a lot of volunteer events. So since July of 2023, we've actually removed over 21,000 pounds of marine debris. So we're out there, thank you. We're out there getting people involved as best as we can, educating the youth and engaging the public. We've got a variety of different campaigns. Some of you are probably very familiar with our campaign, so I won't get into it too much. Feel free to come talk to us at the end more about it. We are excited to be here to support Dr. Lapointe and the Lower Keys League of Women Voters. Dr. Lapointe has a rich history with Reef Relief, and one of our big things that we are concerned about is water quality. It's something that we have been pushing for and vouching for since 1987, our inception. So we are excited for you all to learn more about our water quality and help us fight this fight to improve it as best as we can. So thank you. I'm going to pass the mic to Mary from Last Stand.
Hello, I'm Mary Splain. I'm representing Keys Last Stand. And Last Stand was formed in 1987 as a permanent umbrella organization to quickly respond to environmental and community issues that arose. Our mission is fairly simple. We want to protect the quality of life within the Florida Keys and preserve our natural environment. Right now, water quality isn't just a concern, it's a crisis. The recent reports of fish kills, erratic fish behavior is just devastating. For over 36 years, we've been working to address water quality concerns throughout the Keys, and we especially oppose the shallow sewage wells that pollute our nearshore waters. That's why we're thrilled to be here tonight. We're thrilled to hear what Dr. Lapointe has to say about what's going on. In January, we had the privilege of having him speak at our annual meeting. And like him, we want to follow the science. We want fact-based solutions to what's going on. I'd like to thank the League of Women Voters for inviting us to participate in this, and we're always glad to partner with our friends at Reef Relief and the City of Key West Sustainability. If anyone would like more information about Last Stand, please stop by. We'd be glad to talk to you. Thank you very much.
It's great to see so many faces I recognize in the audience. Allison Higgins, I'm the Resiliency and Sustainability Coordinator for the City of Key West. Ditto on what everybody else said. We're very excited to be here today. One of the things I'm pretty excited about is in our strategic planning process, which we started a couple of years ago, environmental protection was rated as one of our top 6 priorities. It was number 4 by the people who participated in the survey, which is about good 4,000 people. And water quality was one piece of that. We decided that we didn't know enough because we don't have marine biologists on staff. And so we convened a group that is somebody from FWC, somebody from FDEP who's in the room. We've got somebody from Extension Service, and then later also got joined by somebody from the College of the Florida Keys and Reef Relief and Moat. And I think I got them all. If I didn't, I apologize. We went through the National Marine Sanctuaries Water Quality Protection Program list of priorities and looked with an eye of what can a city do? What can we at the local level do? And we came up with 11 priorities. I'm proud to say that we turned in a budget. Two things. We already have been spending, we do a lot of water quality testing. We were finally able to turn a lot of that into the big state database that's now available. We tested all of our outfalls and we tested our marinas. One of the things we recently started doing from the strategic plan was partnering with the College of the Florida Keys on the work they'd already started in looking at the effects in our harbor. But we also partnered with them on a second grant to look at certain areas of concern, whether it was not ammonia, but sucralose around the liveaboard boaters, hydrogen sulfide potentially around Mount Trashmore, and oxybenzone at our beaches. So those studies are still just kicking off, but we also put in, besides the money that we've been investing there, this will be our second year of $100,000 towards coral reef restoration that we give to Moat. Both CFK and Moat just presented at the City Commission. So if you look at our April 3rd meeting, you can see what they've done recently. Our 11 things and the budget I turned in, which hasn't been ratified yet for FY25, are in the back there. Also in the back, you'll find we are mostly set up for our adaptation plan. There's big things we're trying to do to get ahead of the rising seas. There's a survey and other things you can do to stay involved with what we have going on there. And the last thing, at the Sustainability Board meeting today, we presented to them about the bond. City of Key West voters will have a chance to vote on 4 different referendum questions on whether you want to tax yourself a little bit more in order to achieve certain big steps in either police and safety, parks and rec, adaptation, or roadways and parking. So if you want to learn more about that, you can also tune in and see that presentation at the Sustainability Board from today. I know I took up a lot of time, but you don't often get this many people in one room. So with no more further ado, I am honored to turn this back over to you.
Thanks. Hello, I'm Liz Levi, and I'm a member of the League of Women Voters. And I want to say just a few words to introduce our speaker, who is kind enough to come to us from Big Pine, and tell you a little bit about him. Dr. Brian Lapointe is research professor at Florida Atlantic University, the Harbor Branch Oceanographic Institute in Fort Pierce. He is internationally renowned for his research on nutrient pollution and harmful algal blooms in tropical and subtropical waters, and on their effects on the health of seagrass and coral reef ecosystems. Brian holds a bachelor's degree from Boston University, a master's degree from the University of Florida, and a doctorate from the University of South Florida. Since 1982, Brian has been a part-time resident of Big Pine Key, and this has allowed him to pursue his long-term research on water quality in the Keys. Brian's research has been published in 133 scientific publications, and he has advised several government agencies and governments of other countries on water quality monitoring programs. His work throughout Florida and the Caribbean region has been used by policymakers to improve stormwater and wastewater infrastructure to help mitigate the increasing environmental, economic, and health impacts of harmful algal blooms. With that, I'll turn this over to Dr. Lapointe.
Great. Thank you. Well, thank you very much. Can you hear me all right? Okay, excellent. Well, looks like a full house tonight. Nothing like a crisis to bring out the riffraff, right? So we're gonna take a little journey tonight. I want to thank Liz first for the invitation and all the other sponsors. It's great to be back in Key West. It's been a while since I've been here to lecture on my research that started on Big Pine Key. My career really started when I arrived on Big Pine Key in 1982. And I study nutrient pollution and harmful algal blooms, particularly macroalgae, these seaweeds like you see on the screen. This is Pine Channel just recently. And what we're seeing here in this photo are macroalgae, red and green and brown, overgrowing a turtle grass meadow. Now, we've all seen these blooms expand in our shallow waters. They follow stone crab traps, lobster traps, and they can cause hypoxia, low oxygen conditions on the bottom beneath these because they photosynthesize during the day, but at night they respire and take the oxygen out of the water. But what I'd like to do tonight is actually, and I know this is really all about spinning fish and of course the die-off of the endangered sawfish. This has gotten international attention, but we also just heard from a state biologist urging caution to swim in the water. So this indeed is a crisis, and it's not the first one, and it probably won't be the last one. But what I'd like to do is really kind of go up to the 50,000 foot level and talk about what's happening all around the globe with this issue. The global nitrogen overload problem is something that I've been studying really going back to the 1980s. And this is one of the primary drivers of the expansion of harmful algal blooms we're seeing worldwide, but especially here in the state of Florida. We're going to look at the sources of nitrogen that are driving these blooms, both locally here in the Florida Keys, some of the early work I did supported by Monroe County, and on the mainland as well. And we're going to see how nitrogen enrichment in these algal blooms relate to the decline of corals on the Great American Barrier Reef, our own reef here in the Florida Keys. Then you all have heard about the Great Atlantic Sargassum Belt. That's been impacting us for really since 2014 in a big way. I'm going to talk about that. That's related to nitrogen enrichment. And then we're going to end up talking about what has happened this past year, 2003, 2024. Unprecedented heat, algal blooms. You all remember what the water quality looked like last summer during mini lobster season in the lower Keys. The El Nino weather pattern that created a very wet winter. And of course, then the spinning fish and the mortality of the critically endangered small-tooth sawfish. And we'll end up with some recommendations about what can be done. So to begin, looking at how human population growth is changing the nitrogen cycle. Nitrogen is the key limiting nutrient to algae blooms worldwide. And this is going to be the story I'm going to bring out tonight about toxic algal blooms that the evidence is showing is involved in the fish spinning that we're seeing. So the nitrogen from human activities, this is a paper published back in 2009, this figure, and it shows how nitrogen has essentially been doubled on our planet. This is reactive forms of nitrogen like we have in fertilizers, but it also comes from human population growth and wastewater flows. we've more than doubled the amount of nitrogen on our planet. And actually, most of the fertilizer use has been since 1985, okay? But we're adding 121 million tons a year of nitrogen to our oceans, only 9.5 million tons of phosphorus. So if you look at the ratio, it's 28-1, 28 parts nitrogen to 1 part phosphorus. The ocean is 16-1. So in addition to increasing the concentrations of ammonia and nitrate and phosphate that cause these algae blooms, both toxic and non-toxic algae blooms, we're altering the ratio of these nutrients, and that is having profound effects above and besides the concentration effect alone. And you can see that red, the nitrogen, how we have exceeded the safe operating space on our planet in terms of the excessive nitrogen coming from human population growth. The other factor that we have exceeded is genetic diversity, the loss of biodiversity, which is connected to the increasing nitrogen. Dead zones in our ocean, okay, where you lose that biodiversity. And we've seen that right here on our coral reefs and our seagrass beds. And I'm gonna show some examples of that. So it is these nutrients, particularly nitrogen, that is driving this expansion of harmful algal blooms like we're seeing in the lower Keys right now. Pre-1972, we had harmful algal blooms. In fact, we had ciguatera in the Florida Keys. If you probably can't see those little purple squares at the tip of Florida, but if you can, that's ciguatera, fish poisoning, caused by Gambra discus, a little toxic dinoflagellate. Has anyone had ciguatera fish poisoning in here? So you know it's serious. It's something you don't want to mess around with. Look at post-1972, how the expansion of these harmful algal blooms began, all around the coastlines of the United States. Let's see, it was 2006 when Ken Weiss with the LA Times came and interviewed me here in the Florida Keys and up in Miami-Dade County for an investigative report he was doing on this topic for the LA Times. In fact, that's a picture of me with my research assistant, Chip Baumberger, another part-time resident of the Lower Keys, at 90 feet off the Hollywood sewage outfall. Front page of the LA Times. It was shortly after that came out, this investigative report, that legislation was passed to phase out the sewage outfalls. Our research using nitrogen isotopes to trace the source of the nitrogen showed compellingly that the nitrogen was coming out of those pipes. And DEP and our legislators developed legislation. They're being phased out. 2 of the 6 are already gone. But that nitrogen source caused these algal blooms over the coral reefs in Miami-Dade, Palm Beach, and Broward counties. So today we have more harmful algal blooms, more toxins, more toxic algal species, more fisheries affected, more areas affected, and we're seeing that right now in the Lower Keys, higher economic costs and more public health impacts. And I was part of a group of scientists in the early 90s that got together at Snow Mountain Ranch in Colorado to develop a national plan for research and response. It started with the EcoHab program that was been funded by NOAA and other agencies, and more recently, the Harmful Algal Bloom Research and Response Program. So today, virtually every coastal state, including the Great Lakes states, are being impacted by these macroalgae blooms. Now, some of these can have toxins, but for the most part, they're not like red tides that produce a toxin that causes human health impacts. Another area that's heavily affected by macroalgal blooms are the Hawaiian Islands. In fact, on Maui, that's probably some of the most famous macroalgal blooms, overgrowing coral reefs. So where do those nutrients come from? They come from shallow wells. In Maui, obviously, a major tourist destination like the Florida Keys, but they don't have advanced waste treatment. They have secondary level treatment. So they have high concentrations of nitrogen and phosphorus, goes down a shallow well and migrates through the groundwater to the coastal reefs that are covered with thick mats of macroalgae. I got to write a review on this subject of harmful macroalgal blooms in a changing world for this book, Harmful Algal Blooms, a compendium desk reference. So if you want to know more about this subject, you could get a copy of the book. So my research started in 1983 or so after I moved to Big Pine Key. And those two photos on the left are our little aquaculture project where we were growing different seaweeds, dosing them with nutrients to look at their response. And this was part of a project to try to grow marine biomass for biofuel production. And does anyone recognize those two seaweeds that we were growing back then? Sargassum. So we thought these were great target species because they float out on the surface of the ocean. If we could recycle our wastewater or nutrient waste to produce this biomass and digest it for biofuels, this was being looked at very seriously and actually still is. But we now know, as you're going to see, the Great Atlantic Sargassum Belt, we don't have to add too many nutrients to the ocean anymore. They're blooming by themselves. The middle two photos are Lou Key, where we started a long-term monitoring program. And in order to monitor these nutrients like ammonium, nitrate, phosphate, they're present at part per billion levels in our coastal waters. So we need really good analytical equipment, these Technicon auto analyzers, Braun and Loewe analyzers that we had here in the Florida Keys in the beginning, but now we have those facilities up at Harbor Branch in Fort Pierce. So one of the first things we did in Pine Channel was looked at the seasonal variation in nutrients. And this is nitrogen in Pine Channel. Now this is very interesting. I was just looking at these data a couple months ago when I decided to put this in tonight because 1983, when we began this research, was one of the strongest El Niños on record. Heavy, heavy rainfall here in the Keys in January. You see how high the dissolved inorganic nitrogen is far on the left. The next month, February, you see how it goes way down. We got into a typical dry season then, and you can see how then through the spring months up into August, when it peaks in the summer wet season, obviously we're getting a lot of runoff from around Pine Channel, the various watersheds, and then it goes down through the fall. So this is kind of a typical seasonal cycle of nitrogen in our coastal waters. But that peak in January is similar to what we saw this winter with all the rain that affected runoff, not just locally here in the Keys, but also, as you're going to see, from the mainland as well. Now that black dashed line, that marks the threshold. Above that line, these algae are saturated with nitrogen. They don't need any more. And that's why in the summer months or during the El Nino period, they're not limited by nitrogen. They're saturated. They're limited by phosphorus. They're the next limiting nutrient, okay? So we looked around, where's all this nitrogen coming from that's creating these blooms of macroalgae in Pine Channel and supporting the growth in our experiments? Well, we didn't have to look too far. We had thousands of septic tanks on Big Pine Key, Little Torch Key, some on Middle Torch. And I worked with the county. We had a grant from the state of Florida back in the mid-1980s to put monitor wells up and down the Florida Keys on different residential lots. And we found, sure enough, 5,000-fold enrichment of nitrate and ammonium in the groundwater moving sideways. We had a groundwater flow meter that showed how heavy rainfall events transports those nutrients into the coastal waters from the groundwater. And even tides, just tides ebbing, causes tidal pumping, okay? The groundwater accelerates as the sea level goes down relative to the groundwater level. So what happens as these septic plumes move through that limestone water, the phosphorus is absorbed. The nitrogen is not. And so you get a very high nitrogen to phosphorus ratio as it comes out into the surface waters. In this case, an average of 100 to 1. Remember, the ocean is 16 to 1. So what we're doing, we're starting to drive our coastal ecosystems towards phosphorus limitation as the nitrogen builds up. And of course, the good news here is that we now have the Cudjoe Regional wastewater treatment plant that has 5-stage Bardenfo, removes 98% or more of the nitrogen. And with a deep well injection facility, I know they're having some issues with that, some scaling issues, and periodically have to use the shallow wells. But hopefully they're going to get that solved and keep all those nutrients down, even though they're at low concentrations. The problem now, as you just saw, the concentrations are so high in our coastal waters, there's no dilution capacity anymore without creating these algae blooms that we're seeing. So look at this map of Florida. The pink and the red are septic tanks on the mainland of Florida. 39% of Floridians rely on septic tanks. And, you know, for many years, as we saw algae blooms develop in the iconic Florida Springs up in the Panhandle and north central Florida, everyone thought, oh, it's the fertilizers, it's the farmers, right? And there are a number, you know, of papers and white papers that came out. But then as more and more research was done, and a lot of that was done by yours truly, using stable nitrogen isotopes, sucralose, and other tracers of human waste, the fertilizer amount and contribution to the nutrient pie went way down from being the dominant source to being a lesser source. So this is the final study of Wakulla Springs, south of Tallahassee. 51% of the nitrogen is from septic tanks that's causing the blooms in the spring basin. Another 6% is coming from a wastewater treatment facility. So almost 60% is coming from human waste. Fertilizer from farms in that basin, 8%, urban fertilizers, 5%. So about 13% from fertilizers. So it's obviously important if we're going to manage this problem, we've got to know the source of these nutrients. And the good thing is fertilizer applications in Florida have gone down tremendously. You see the blue line, that's tons of nitrogen decreasing. It's a half of what it was in 2003. And the orange line is phosphorus. 80% of the fertilizers in Florida are used by the farmers. Okay, and we know from a lot of research that IFAS has done that the urban use of fertilizers on urban turf grass, they're finding if you use fertilizers according to the Florida-friendly guide, then the turf is taking up about 90% of that fertilizer. So if you fertilize your yard according to the state recommendations and you have a septic tank, roughly 10% of your runoff is from fertilizer, the nitrogen, and 80 to 90% is coming from your septic tank. Well, let's come back to the Florida Keys now. So as I was starting this research in the 80s, there was a lot of interest in water quality back then because we had a crisis back then. We had algal blooms in Florida Bay, spilling through the tidal channels, green water. Seagrass die-off, 100,000 acres of turtle grass in Florida Bay. So, and we were starting to see diseases on our corals. So this workshop up at the Marine Resource Foundation, Jan Koblick's facility in Key Largo, was attended by 50 coral reef experts and resource managers. We ranked the threats to the coral reefs of the Florida Keys, And these experts concluded excessive amounts of nutrients invading the Florida Reef Tract from the Keys and Florida Bay are a serious and widespread problem. Well, shortly thereafter, 2 years later, the Florida Keys National Marine Sanctuary Act was passed. And of course, we saw NOAA, EPA, and DEP come together to develop a water quality protection plan. And gosh, we thought this was great because we wanted to keep these waters gin clear, keep our coral reefs and seagrasses healthy, because we were seeing that green water in Florida Bay coming through, particularly in the wet season, out towards the reef, and it was starting to take a toll on the corals. Things changed. After the sanctuary came in, there was not much talk about nutrient pollution anymore. Researchers from the University of Virginia who were working with Everglades National Park and were also working with the sanctuary program, they couldn't find any water quality problem from nutrients. They thought the problem was lack of hurricanes. Do we really want more hurricanes in the Florida Keys? And part of that argument, well, it's hurricanes, lack of hurricanes, but also the water's getting awful salty. Super salty water, Solaris Hill, by one of these scientists from the University of Virginia, making an argument that we just need to send more water from Lake Okeechobee down to the Florida Keys. I'm serious. Show of hands, how many people think that would solve our water quality problems? If you think it would you please raise your hand so everyone can see you? That's what I thought. So here we go, decline of corals on our barrier reef was even blamed on the ocean being too salty. I'm not kidding you. It's Miami Herald, excess saltiness killing coral. Zippo, nada science to support this. Nada. This is political science at its best. So here we go, another Keys crisis. Quote, Heather Dewar, most scientists blame a shortage of fresh water that once flowed from the Everglades. You see the dead zone in central and western Florida Bay. When this was written, the water was coming into the bay. It wasn't hypersaline, it was coming in, creating algae blooms in a dead zone. That's how dead zones are formed, like the Mississippi River dead zone. So most scientists blame, like it's consensus building, right? Well, a lot of these scientists were on the payroll, right? Getting grants to do the monitoring of the seagrasses and the corals. That last quote in the Miami Herald about salty water killing corals was Dr. Jim Porter, who is a colleague of mine. And I called him last year. I said, Jim, did you really say the salty water is killing coral? He said, no, I was misquoted. So even he agrees that was fake news, right? That's what we call it today, fake news. So it gets worse. Our county commissioners actually passed a resolution demanding that the water managers, the South Florida Water Management District and the Army Corps of Engineers begin to send all this water from Lake Okeechobee south to Florida Bay and the Florida Keys, claiming that they cut off 90% of our water supply into Florida Bay and the Florida Keys. And that this was what was killing the seagrasses in Florida Bay and killing the corals, creating the green water. Their argument was that the salinity was so high, it was actually killing the seagrasses. The seagrasses were decomposing, releasing nutrients. And that's where the nutrients were coming from. How many of you believe that? It was coming, we know the water that was coming in to Florida Bay from the Everglades has 1.5 milligrams per liter of nitrogen. So the amount of volume that they're pushing into Florida Bay is thousands of tons a year. And actually, this is a cartoon. When this was going on, the water was coming in, the salinity was going down. And this cartoon appeared Florida Bay X'd out, Lake Okeechobee south. And here are the data. So this argument that the water was cut off, all you had to do was go to the Water Management District and look at the data, the flow, and anyone could see just the opposite is the truth. These 4 bars represent averages, water flow in thousands of acre feet per year. So that top 1,000 is 1 million acre feet. Imagine how much water that is. 1940 to 52, 200,000 acre feet. Was anyone around Florida Bay and the Keys in the 40s and 50s, early 50s? I think the water looked pretty good back then. It's pretty clear. The fisheries were in really good shape in Florida Bay. 1953 to 82, that flow goes up over 500,000 acre feet. We still had reasonably good water periodically with excessive flows in very wet years. We were seeing algal blooms, but from 1983 on, we were on average over 750,000 acre feet with peak flows up around over 2 million acre feet, 2.5 million acre feet. And look at 2013, just this recent period that included the 2016 El Nino, averaging about 1 million acre feet, the highest ever. Yet we hear this, the Army Corps of Engineers drain the Everglades and the park is starved for water. There's the data. The water flows have increased, not decreased.
You know what flow was before Tamiami Trail was built?
What's that?
You know what the flow was before Tamiami Trail and the canals?
What year was that? That was,
That would have been early 20th century.
yeah. Yeah, that's not on here. These flows, okay, started measuring in 1940. That's, about the time Everglades National Park was established. So the drainage was before that period, okay? But this has been monitored, these flows, every day since 1939. So the water comes in through 2 routes. Shark River Slough is the major flow coming out just above Cape Sable. And of course, Taylor Slough comes into the Central Bay. Another thing that has not been well understood is the Central Everglades, that water coming down Shark River, that's the bulk of the water, that doesn't really go very far into Florida Bay. The water from Taylor Slough does. So this is what the water looks like at Cape Sable, this green kind of pea soup water. So the more water that comes down Shark Slough, that green water moves down the west side of Florida Bay, and you're going to see in the satellite imagery I'm going to show, is primarily affecting the lower Florida Keys. There's the annual flows, and on the left is Shark Slough. You see the 3 circles or ellipses. You can see how during wet periods, roughly every 10 years with these El Nino events, we get much higher flows, both because of deliveries, but also because of the rainfall. About 70% of the flow from the Everglades, from the water conservation areas, is rainfall. But you can see how it's ramped up with that peak flow in 1995 coming out of Shark Slough. And Taylor Slough, same thing. You can see how the flows have gone up. And after those flows and the algal blooms they create, that's when we see the seagrass die off in Florida Bay because of the light attenuation and all the organic matter that creates cryptic hypoxia, low oxygen in the sediments. Here are the satellite images showing the turbid green water from Cape Sable coming down. You can see there's a filament moving out through channel number 5 in the middle Keys, but that bloom in 1996 following that maximum year went all the way out to the Tortugas. And we saw a repeat of that just in the Central Bay in 2013 following releases of water in the Western Diversion Project, one of the first major achievements of the Everglades Restoration Plan to put more water in Central Florida Bay. So during these periods, we saw seagrass die off, sponge die-offs in Florida Bay, and of course, problems downstream on the reefs. And this is what happened as that water flow increased over the years. Those black bars are the rate of coral loss per year. About 1% in the 70s, jumped up to 5% in the 80s. And with the big flows of the 1990s, up to 10% loss of coral each year. That was 4 years, 1996 to 2000. We lost about 50% of the living coral in the decade of the 1990s when all this was going on. And by the way, this is the rock pile reef over time from 1988. Before and after all that water came in, you can see how these brain corals did not survive the restoration plan for the water quality protection plan of the sanctuary. Those brain corals are large, hundreds of years old, and were kind of lost within a few years, overgrown by algae and sponges. We captured the data in our long-term monitoring at Looe Key, which was being affected. We have, again, in this particular paper we published in the journal Marine Biology, we saw over these 3 decades, the nitrogen increased offshore at Looe Key, and statistical analysis of all the data, temperature, chlorophyll A, all the different nutrients, phosphorus, nitrogen. The driving factor, according to the data of these biological changes, the loss of coral, showed that nitrogen was the significant factor causing this problem. Okay, but what was interesting, the other significant relationship we found was chlorophyll A, which is a measure of the algae in the water. As it goes up, the nitrogen to phosphorus ratio goes up. Again, because all that nitrogen, that high nitrogen to phosphorus water coming out of the Everglades and off the islands of the Keys drives these blooms to high degree of phosphorus limitation, driving that ratio up. And that becomes very stressful to the corals. We know it went up at Looe Key because we measured it in macroalgae growing right next to the corals. We see the data, the N to P ratio for the 1980s, and look how it jumped up in the 1990s to the 2000s and beyond. There's that Redfield ratio of 16:1. So corals have dealt with high temperatures before, high CO2. Never have they ever had to deal with high nitrogen and high nitrogen to phosphorus ratios in combination with these other stressors. So what it does when that N to P ratio goes up, this a really great group of scientists at University of Southampton, they've shown that these coral reefs have evolved under low nitrogen, low phosphorus conditions, very clear, low nutrient water. Now they're seeing high nitrogen, low phosphorus water, really skewed stoichiometry, as we call it. And what that does, that creates stress in their photosynthetic mechanism, making them more susceptible to high light and high temperature, i.e. bleaching. And it also, the corals that seem to be most susceptible to the effects, the physiological stress of the high N to P ratio are the branching corals, elkhorn and staghorn coral. They were the first to be lost, right? It makes sense. So this is a recent paper in Global Change Biology, conducted right here in the Florida Keys, how chronic nutrient enrichment increases the prevalence and severity of coral disease and bleaching. Now that was a nice little small scale study with experimental plots, but let's face it, we had a huge ecosystem scale study, right? A big nutrient dosing study as those flows from the Everglades came out and caused increased nutrients. These are the photos going back to the 1980s following the flows showing the bleaching effect. And it's not just nutrients, of course, taking the coral cover down, but pathogens. Kate Patterson at University of Virginia showed how Serratia marcescens, this white pox disease from humans, human gut, rod-shaped gram-negative bacterium, causes white pox disease. But black band, yellow band, and of course, more recently, what's referred to as stony coral tissue loss disease. Between 1996 and 2000, over 400% loss of coral. And of course, this is what the headlines look like back in the 90s. We had a red tide, a toxic dinoflagellate bloom in 1995 during the peak flow in nitrogen loading. So that bloom normally is up off Southwest Florida. With all that fresh water coming down, that red tide moved right into the lower Florida Keys, okay? And you can see Mark Caputo's article, The Bay Remedy Could Be Backfiring, right? Killing a lot of wildlife in the Keys. So finally, by 2002, after seeing all this, the National Academy of Sciences, the Committee on Restoration of the Greater Everglades Ecosystem, said, you know what? Everglades restoration is sending all this water down there. It's going to harm Florida Bay. And eventually they said the Florida Keys coral reefs as well. And so unfortunately, the next year we were designated as an official dead zone by the Pew Oceans Commission report. And of course, we had lost a lot of coral at that point. And the reason it was declared a dead zone is because of low oxygen. A dead zone is defined as a body of water that is receiving increased nutrients, algal blooms that are consuming oxygen, causing hypoxia. And this is the oxygen just showing at Looe Key how it goes up in the daytime with photosynthesis and down at night as photosynthesis stops. And it's getting very low. That bottom number is about 2 milligrams per liter. The state standard, you got to have 4 milligrams per liter in the water. So this is offshore at Looe Key. So obviously this is a major stressor to the corals as well. We saw this most recently, 2013 to 20, again, when we came into another wet period. The NDP ratios were low in 2009 to 2012. We had come out of a multi-year dry period. And look, as more runoff and rain come into the system from 2013 to 2016, the yellow colors, that NDP ratio is going up. And then following Hurricane Irma, 2017 to 2020, epic runoff. And we are seeing NDP ratios up around 81 and higher on our outer reefs from all that water runoff, mostly from the mainland, but also from the Florida Keys. And this is when we saw very rapid decline and regional extinction of pillar coral in the Florida Keys. And a really nice paper by Karen Neely and co-authors really referring to this now as a functional extinction of pillar coral. Now, there is still pillar coral around the Caribbean, but not so much here in the Florida Keys. So that takes us to the other insult we're seeing now, the biggest algae bloom on Earth, sargassum. In 2011, we saw this bloom form in a part of the ocean we had never seen sargassum before. We know it's been in the Sargasso Sea up in the north central gyre, but here it is stretching across from Africa, across the tropical Atlantic, through the Caribbean, up into the Gulf of Mexico, 8,850 kilometers long. And this is the most recent update. You can go to the USF Optical Oceanography website and get monthly updates on where the sargassum is. And this is the April update. You can see those red dots are major, huge patches of sargassum moving into the Caribbean. So we're going to be seeing that over the next couple of months. We're already starting to see some. Mexico's starting to see some as well. And this is an animation just to show you the river runoff from these major rivers in the Atlantic Basin. You can see the lower salinity, the white, green, and blue colors as we run through the years, how these river discharges carrying nutrients are feeding that sargassum bloom, okay? You can see, in fact, how the white, green stretches entirely across the equatorial Atlantic region, showing you how extensive these river plumes are when these rivers are flowing. Amazon, the Niger, the Congo River, the Orinoco, the Mississippi River. Those plumes ride out over the ocean surface, carrying elevated nutrients that feed the sargassum. We published a paper a couple of years ago showing how the nitrogen is going up in the sargassum in the open ocean as a result of the rivers, but also atmospheric deposition of nitrogen as well. And look at the N to P ratio has gone up to 28:1. That's exactly matches the load, the human load of nitrogen and phosphorus to the oceans. And this was just last year, last April, just showing how the sargassum comes in and decomposes, releases more nutrients, triggers other algal blooms, okay, in our coastal zones, reduces the pH. This is coastal acidification from all this biomass decomposing. It creates dead zones, hypoxia and anoxia, toxic hydrogen sulfide, heavy metals. Sargassum has a lot of arsenic in it, so you have to be careful if you're collecting it and using it as fertilizer. And it also contains rafting dinoflagellates, these little dinoflagellates that I'm going to talk about in a few minutes. So we're now wondering if this has been important input of these dinoflagellates that are producing toxins in our water. So last year, it was like living in a pizza oven last summer. This is the accumulated heat stress going through the summer last year. And we know that these toxic dinoflagellates are moving to the north as the oceans warm. So that may be one thing that has contributed to these unprecedented toxic dinoflagellate blooms that we're seeing. Potential sources of discolored water that we saw last year extend all the way up to the Mississippi River. Plume had a lot of rainfall west of the Mississippi last year. There's a little filament, you can say 1A, that is caught on to the side of the loop current and moved down into the Florida Keys by the summer. And we also had a lot of discolored water coming in from the Southwest Florida shelf. And look where it comes. That water, whether it comes out of Shark Slough or the Caloosahatchee, as it moves down, it's coming right down to the lower Florida Keys. And here's another plume bloom feature following Hurricane Idalia, a major diatom bloom. On the left, you can see the amazing extent going way offshore, Southwest Florida. And again, it wraps all the way down and around the Florida Keys. And getting closer to home, Everglades discharges in the wet winter, the El Nino winter we just had. Again, look at that first image on the left, showing that bloom right there at Shark Slough, just above Cape Sable, coming right down to the Florida Keys. And then as we go through the winter, we see a lot of that discolored water hanging around the lower Florida Keys. In fact, in March, when I'm going to show you some data on these toxic dinoflagellates, you can see that turbid water right there, ocean side of the lower Florida Keys. This is another set of imagery from the Sentinel-3. Again, August 8th, look at that bloom. That's chlorophyll, that green color. And if you look at Cape Sable and Shark Slough, look at that filament coming right down once again to the lower Florida Keys. January 5th, okay, when we're really starting to see the fish spin and the problems with the small-toothed sawfish, look at the bloom on the north side of the lower Florida Keys. Once again, You don't see it affecting the middle and upper keys as much as the lower keys. That is what the water looked like in August, okay, in Bow Channel. You all remember the algal blooms we had last summer, some of the worst water we've ever seen. It looks very much like the water up around Cape Sable at the mouth of Shark Slough. So now I'm going to show, for those of you who haven't seen the spinning fish, this video was courtesy of Greg Furstenworth, who has really done a great job documenting the different species that are spinning in our waters, along with his wife, Shaylee. So let's see, this is a Goliath grouper. Most of this is in Pine Channel. So well over 50 species of fish have been affected at this point, and a number of invertebrates, including stone crab.
Has anyone checked to see if there's any contamination in their,
In the fish? Oh yeah, I'm going to get to that.
Excuse me.
Yes.
If anyone has any questions, we have to use the microphone.
Okay,
And
yeah,
Jason, if you have it, maybe you could give
yeah.
the microphone.
Look at that snook. Mhm. And a sawfish off Boca Chica Beach. Stingray, and apparently one of these were just reported, I think, in the last couple days in, I think, in Marathon or maybe out in Florida Bay. Anyway, this is what's being done with the spinning fish mystery. And I'm not part of this official research program. It's being led by FWC and its partners. And it is, and these slides have been provided to me by Dr. Allison Robertson at the University of South Alabama, who her role in this research is to look at specifically the toxins that are present in the water and the fish. And anyway, these are from her, courtesy of her. And there are a lot of people involved in this research project. The help of local guides, the Lower Keys Guides Association, Bonefish and Tarpon Trust, they're collecting water, algae samples, fish and invertebrates, okay? And they're being tested for contaminants, legacy contaminants, metals, wastewater, pharmaceutical, pesticides, herbicides, toxins, nutrients, viruses, pathogens, microbes, and overall health assessment. And what they know so far is many types of fish are being affected, greater than 50, and it suggests that the stressor is waterborne versus dietary. A variety of benthic algal cells on macroalgae are elevated compared to the baseline monitoring. This is from Mike Parsons' work at Florida Gulf Coast University up in Fort Myers. The natural algal toxins are being found in the water, in the algae, and symptomatic fish, okay? And also, Allison reported to me algal extracts from these toxic algae, these dinoflagellates, when added to aquarium with fish, they do cause the fish to spin, okay? So it looks like the red tide and other species like pyridinium are not present, nor are their toxins. Low oxygen, low salinity or temperature, they don't seem to be playing a role. Disease or parasites also don't seem to be playing a role. The typical pollutants of concern are present in the fish, but are ambient and do not explain the behavioral effects that we're seeing in the fish. So what are these toxic dinoflagellates? Well, there's a picture of them. And this is Mike Parsons' work, sampling from February through late April. He found elevated benthic dinoflagellates in the lower Keys, including multiple species of Gamber discus, Prorocentrum, and Coolia, okay? And you can see the different species here. The Coolia is the kind of small red cell. The Gamber discus is the larger red cells. And then the Prorocentrum are those kind of yellowish, smaller cells, mid-sized cells. University of South Alabama, Dauphin Island Sea Lab, Allison Robertson's work, she's detected levels of benthic Hab toxins, including Caribbean ciguatoxins, gamberones, madotoxins, okadaic acid, and a variety of other lipophilic and benthic algal Hab toxins. So we have a cocktail of many toxins in the water and many blooming dinoflagellates as well. Analyzed but not detected to date are, again, the red tide toxin, brevetoxin, saxitoxin from pyridinium has not been found, domoic acid, the microcystins and anatoxins from the blue-green algae blooms that we have up in Lake Okeechobee, that's not being found. And many other toxin classes have been ruled out. So more and more, it's looking like these little dinoflagellates. And here are the toxins. The Caribbean ciguatoxins on the left, the gamberones on the bottom left, madotoxins and okadaic acid on the very right. So we got to sample a little bit. My citizen science friends in and around the lower Florida Keys. We started a monitoring program March 3rd and 4th. Chip Baumberger, who lives on Little Torch, Greg and Shaylee Furstenworth, and Scott Hutchinson. Over those 2 days, we hit 9 different sites. We started out at the Newfound Harbor Patch Reef off Little Palm, hit 2 sites in Pine Channel, the Little Torch Canal System. Then in Bow Channel, we hit the Sugarloaf KOA and then the Cudjoe Gardens Canal. 2 sites on the northwest side of Cudjoe Key, close to the Cudjoe wastewater treatment plant. There are a lot of people thought that perhaps, there were shallow wells, with leachate wastewater coming out into Bow Channel. And then 1 site way up at Tarpon Belly. So we collected these water samples for dissolved nutrients, chlorophyll A, dinoflagellates to see what was in there for dinoflagellates, toxins, and sucralose. So what we found was quite a bit of ammonium in the water. The highest on the left, the 2 highest bars are in the canal systems, Little Torch Canal and Cudjoe Gardens Canal. So of course these canals have been loaded with wastewater for a long, long time. There's still legacy nutrients in those canals. It's going to take a long time for those to clean up. But we had relatively higher ammonium over in the Bow Channel area compared to Pine Channel, but not crazy high, but slightly higher. So that's something we certainly need to look at. Look at the total dissolved nitrogen, okay? That black line is the numeric nutrient criteria for total dissolved nitrogen. We're about 2-fold higher than that standard. So there's too much nitrogen in the water. We need to follow that and see if that's a short-term, kind of a one-off enrichment with some of this water moving in from the north. And then look at the total nitrogen, total phosphorus ratio on the right. Values up to over 400 to 1. We have never seen that high a nitrogen to phosphorus ratio ever in all our 40 years of research in Pine Channel. So that's Pine Channel, Newfound Harbor Reef. The Little Torch Canal was up, and Pine Channel. Pine Channel having the highest. So Was that a parcel of water, perhaps, from Shark Slough? You saw the satellite imagery that came into the Lower Keys and was being fed more by local nutrients. But regardless, we see that N to P ratio as a tracer. And we see lower values of that N to P ratio in Bow Channel. Sucralose, the only fairly, moderately high level, it's not really high, is in the Little Torch Canal, 60 nanograms per liter. What we consider high is a value like 2,900 nanograms per liter that we found in Boot Key Harbor that was associated with the shallow wells where the wastewater was coming up in the Boot Harbor. So those values of 20 to 30, those are kind of background levels of sucralose that we found in Bow Channel. So we're not seeing a lot of evidence that there's a lot of wastewater in Bow Channel. What's that?
Sucralose.
Sucralose is an artificial sweetener. It's widely used and it's a great tracer of human sewage. Yeah, because it's very conservative. It goes right through sewage treatment plants, through septic tanks. We use it a lot in our research. So the dinoflagellates we sampled on April 3rd, after we realized from our first sampling, we did see a lot of these dinoflagellates up in the water column. These are benthic dinoflagellates that typically live on macroalgae or seagrasses on the bottom. So we thought, man, if we're seeing this many up in the water, there are going to be really high numbers living on the seaweeds on the bottom of Pine Channel. And sure enough, working with the NCOOS lab up in Charleston, South Carolina, the Hollings Marine Lab, Dr. Steve Morton and his assistant Andrew, they did the counts for us on a scanning electron microscope. And this green filamentous algae that many of you have probably seen had really high cells of prorocentrum. You remember that little red cell we saw in the photograph a few minutes ago? 10,000 cells per gram, okay? That's a lot. And then Digenea, another seaweed, and Laurencia, we still saw thousands of cells, which really corroborates, it agrees very well with what Mike Parsons saw in his count. So I think we have, a lot of agreement that we have a bloom in unusually high numbers of these benthic toxic dinoflagellates in these waters. Now, where it gets really interesting is you can have these dinoflagellates, but they don't necessarily produce toxins unless the environmental conditions are just right for toxin production. So I was looking through the scientific literature on prorocentrum since it was so abundant, and I ran across this paper in the journal Harmful Algae by these Italians who actually worked with prorocentrum from the Florida Keys. And essentially what they found was at warm temperatures, 27 degrees, and high nitrogen to phosphorus ratios, which creates like a nutrient stress in these algae. They start to pump out the okadaic acid, the toxin. Those are the conditions, almost exact conditions we found in the water quality data. Our temperature was, I think, 26.4, and our N to P ratio was 4 to 500. Theirs was 600 or 700 in their experiments. So we think we may have not just these dinoflagellates there, but the conditions that induce toxin production. So just to recant all this, we really had a perfect storm in 2023, 2024 of environmental stressors. The sargassum arrived early, last February. That was actually the first observation of spinning fish made by Greg. And summer 2023 was extremely hot, very high rainfall east of the Mississippi River, forming a 10 to 20 meter thick salinity plume containing a diatom bloom that reached the Keys in August. We had the Cat 4 hurricane in late August, Idalia, more runoff and blooms. The winter 23-24 wetter than average dry season, and increased runoff from Shark Slough and Taylor Slough. And finally, high nitrogen and high N/P ratios in the lower Keys, together with warm temperatures in March and April, provided ideal conditions to support algal blooms and toxin production in some of these benthic dinoflagellates. It shouldn't be surprising because we see these harmful algal blooms following these major extreme rainfall events and hurricanes. Hurricane Irma, 2017, 2018, we had just epic flooding and runoff, caused a brown tide in the Indian River Lagoon, red tide on the west coast of Florida, blue-green algae bloom in Lake Okeechobee and the downstream northern estuaries, and that was one of the peak years for sargassum as well. So just to wrap up, we really need to continue local inshore water quality monitoring for nutrients, these benthic dinoflagellates, other contaminants of concern like sucralose and other tracers of human waste, just to make sure that our new wastewater collection and treatment system is working as we hope it will. Heavy metals, arsenic, we don't know if mercury and arsenic were playing a role in any of this. Pharmaceuticals and PFAS. A paper just came out in the Science of the Total Environment showing that Monroe County has the highest PFAS concentrations of any county in Florida in the drinking water.
What is the definition?
PFAS are these forever chemicals, right? Yeah. And 79.4 nanograms per liter, maximum 101. This paper just came out. And so we need to address the remaining septic tanks, shallow injection wells, and obviously the PFAS in our water supply. And I'm sure the aqueduct is going to be working on this. Improving monitoring of algal blooms and runoff from Southwest Florida and the Everglades to protect Lake Okeechobee and everything downstream. This is our watershed that goes all the way to Orlando. We need more water storage and treatment north of Lake Okeechobee. That will help protect everything to the south. We need a seascape. I think many of you have seen how the mangroves are expanding, sometimes at the expense of seagrasses. Obviously, our coral communities have changed a lot since the 1970s. It would be really good to look at aerial photography and go back and look at how the Florida Keys, on a big scale, are changing, how these ecosystems are either shrinking or expanding. And finally, I think as you saw tonight, we have to use sound science. We can't use politics to solve these problems, okay, to improve water quality on the mainland and right here locally in the Keys. The Keys, our waters would struggle enough just from our local wastewater and stormwater. But when you have that volume of water coming from the mainland, it's a double whammy. And you go to the Bahamas, you go to other areas of the world that don't have runoff like that from the mainland, and you can see the big difference in the stress on their coral reefs and seagrass ecosystems. So I just want to wrap up by thanking some two scientists in particular that have really helped me advance my career into space, really, to monitor these algal blooms with satellites. Charlie Yench, who I think a few of you know, he was a Key West resident here for many years. And I think I met him in a bar on Duval Street, I think. We both worked at Woods Hole Oceanographic. We shared a very amazing mentor, Dr. John Ryther. So he became one of my closest friends and colleagues. He's the founder of the Bigelow Lab up in Boothbay Harbor, Maine, and he was a pillar in the development of NASA's Ocean Color program. All those satellite images I showed probably would not have happened without Charlie and his team up at the Bigelow Lab. He introduced me to Dr. Hu up at USF. Chunmin and I work extensively together now on the sargassum, the Great Atlantic Sargassum Belt. And then all the local citizen scientists, Don DeMaria, Bill Matsey, Mike Tennell, Maggie Vogelslang, Tanju, who's here tonight, who have all helped collect samples over the years. And last but not least, Dr. Kama Cannon and the Dive into Life program that trains young girls to scuba dive and do undersea research. A really wonderful program. These are the funding sources that have supported my work. And I wanted to just close with this photo from 1991 when I was doing research funded by Monroe County on our wastewater impacts on our coastal systems. John Stormont is in that picture. Mayor Jack London in the middle, and behind Jack is Wilhelmina Harvey. I love that picture. If my house, that's me giving the talk. Yeah, I think if my house was burning down, I would go grab my photos like this. They are so important to me. Anyway, you can visit our website, hboihablab.com. We've got a lot of our papers, a link to Google Scholar and ResearchGate, where all our research papers are available. This is a photo of a Goliath grouper out at Luke Key with an island-sized patch of sargassum coming over it. These are days like this with green water and sargassum are where we see the highest nitrogen and NP ratios. We think some of that is leaching out of the sargassum. So thank you very much. I know it's a lot of material.
Folks, hello, folks. There we go. If you have questions, raise your hand and I'll bring the microphone over to you.
Two quick questions.
Sure.
I seem to recall that $600 million has been earmarked for Okeechobee Everglades restoration just last year.
Mhm.
Who's in charge of spending that money and deciding what's important and where it's going to go? A, question number one. And B, the Hunga Tonga eruption in January of 22 reportedly put about 10% more water into the atmosphere. Do you have any, I mean, it's maybe a different question, but you have any idea what that might do for either temperatures or effects on algae or whatever?
Well, the water would create more runoff, I would think. What goes up must come down, right? Yeah. So this is one of the big stressors on our planet, not just hurricanes associated water, but just extreme rain events. We're seeing more and more of those. So that is what takes those nutrients from land, from human activities into our coastal waters and is driving all these harmful algal blooms. But the other part of your question, so the South Florida Water Management District and the Army Corps of Engineers put together their budgets and projects for the year. They're approved by the governor of Florida. And some of these projects are also co-funded by the federal government. So they are finally starting to work north of Lake Okeechobee more. Most of the money has been spent south of the lake in and around the Everglades agricultural area to treat that water coming down into Everglades National Park. The issue there is phosphorus. So they have to produce water coming into the park that meets a federal standard of 10 parts per billion. That's very low. So they have these stormwater treatment areas that they've built up there south of the lake, south of the EAA for that water to go through to strip out the phosphorus. The Everglades is actually a big filter for phosphorus, but not for nitrogen. That's why it has that high nitrogen to phosphorus ratio. Furthermore, there is no TMDL, total maximum daily load, for Lake Okeechobee. But it's nitrogen that's driving those toxic blue-green algae blooms. They really need to develop a TMDL for the lake to try to mitigate the nitrogen. And most of the nitrogen coming into the lake is coming from the north, 95%. And it's not coming from the farms in the lower Kissimmee is coming from the upper Kissimmee. Have you been up there recently? The I-4 corridor, Disney, the Orlando area? There's a lot of people moving to Florida, number one, 1,000 people a day, but a lot of people are moving there. They don't have advanced waste treatment plants like we have down here, and they have a lot of septic tanks. You saw the septic tank map. So the upper Kissimmee is contributing 1,500 tons a year of nitrogen to Lake Okeechobee. The lower Kissimmee, about 300 and something. So that's not widely known, but that just was published in the South Florida Water Management District, their environmental report. Okay, so I just wrote a paper about this because it's that nitrogen that's driving these toxic blue-green algae blooms in the lake. Yes.
Is the nuclear plant doing something to the waters?
Oh, sorry. Yeah.
Dr. Lapointe, I can't say thank you enough for taking time to come down here and share this history with us and really giving us an overview of, probably what's really going on down here.
Mhm.
You mentioned elevated levels of prorocentrum, the small
Yes.
dinoflagellate, and the associated toxin, okadaic acid, correct? Is
Yeah.
that a neurotoxin? Do you know?
It's, let me think, lipophilic, but it can have neurotoxic effects.
Mhm.
So we typically think of DSP, diuretic shellfish poisoning. Has anyone ever had that? I have, and it's no fun, but you don't typically die from that, okay? However, recent research is showing more broad scale effects, including neurotoxic effects. So a lot of these toxins, we don't know a whole lot about them. You know, you need, scanning electron microscope just to see these little bugs and to culture them and do all this research looking at how environmental factors regulate toxin production, because they don't always produce toxins. They can be sitting there kind of dormant until those environmental triggers appear. But I could not believe it when I found that paper by these Italian scientists that did like the perfect experiment. The effects of temperature and nutrients on prorocentrum. Did they know something? That was published a couple of years ago. They must have been looking at the northern expansion of all these toxic benthic dinoflagellates, because it is happening in Europe, in the Mediterranean, from more tropical waters moving up to more northern regimes. Yes.
Thank you. I'm having a hard time understanding, is the state of Florida held to the standards of the NPDES?
Yeah, the major facilities, like the sewage outfalls, for example, yes.
Okay.
They have to be held to those permitting
Okay, and that's
procedures.
those, again, the major facilities. Who in the state of Florida regulates the septic systems?
The Department of Health. Now, historically, it's been the Department of Health. However, I gave a talk very similar to this in 2019, right after Governor DeSantis was sworn in. The next day, I gave a talk on Florida's septic tank crisis. And one of the things I suggested, because the Department of Health, they don't really monitor water quality, right? And so I thought, this is the wrong agency to be permitting septic tanks. They should be really in the Department of Environmental Protection. And actually that recommendation was enacted. And so it's been moved over to DEP, but I'm not sure what's really happened if, they just changed their name tags, right? So I need to really look into that and see, because obviously these septic tanks are having a major effect on our state's waterways.
And then one final question. What's your frequency of sampling, or where's your oversight when it comes to both the deep and shallow injection wells?
Where's the monitoring?
Yes.
Well, I'm not doing that monitoring. I do little special projects with my citizen scientist friends periodically. we get reports of problem areas like Boot Key Harbor around Marathon. And so I made some time to work with them and go up and collect some water samples. But that's not an ongoing monitoring program of like the deep wells or the shallow wells. There are others that are doing that, I think, possibly with the Aqueduct Authority. Okay, yeah. Yes.
Dr. Lapointe, sorry.
Oh,
I'll bring this right over to you.
okay.
Again, thanks very much for coming here. Very informative presentation. We were talking about the septic systems. Believe it or not, everybody, we have septic systems still not hooked up to our treatment plants here in the Florida Keys. After $900 million of building our treatment systems, there are over 1,000 septic systems that have not been hooked up. Number one. Number two, our treatment plant does not filter out pharmaceuticals or prescription drugs. They have an advertisement on the radio every once in a while. It says, don't flush your prescription drugs down the toilet, but where are they going anyway? Everything's going into the toilet. So we have that issue. Now, you mentioned that, hey, it's great to have advanced water treatment plants like we have here. Well, what good are they if they don't take out pharmaceuticals or prescription drugs? How do you justify that? Thank you.
Well, that is hard to justify other than the technology for removing them. They probably can be removed by ultrafiltration and, very expensive techniques. But that issue, again, is a very understudied issue. I mean, we've had reports, a number of studies showing all these pharmaceuticals in fish tissue. So we know that they're coming from wastewater into our waters and getting into fish. But what effects are they having on fish and humans that eat the fish? I think that's very poorly studied at this point, which may be the reason that not more is being done yet until the science advances on that in that area.
Thank you for being here. Thank you for all the information.
You're welcome.
With the toxins in the water, the toxins in the fish, so many of us are fisher people and the fish or buyers of fish. Are you still eating fish? Should we?
I
How
eat
often?
fish. I'm still eating fish, but they come from way offshore,
So, yeah, can you give us-
and again, once we know more about the levels of ciguatoxin, and like I said, there's a huge, massive project right now. They have not put out an advisory to not eat fish. They have said don't swim in the waters around that area. So I think, when they get further down the road with their research, I'm certain FWC will be coming out with more information on the health risk of eating fish from these waters where these fish are spinning. Yes.
Thank you. Okay, so this is a localized problem. So I do not see really the reason on even talking about runoff, because if the problem were runoff, the problem would be happening up there. I realize there's a combination, but I'm wondering also if it could be, as the gentleman in back said, pharmaceuticals. And I'm wondering if it could be some leaching from our landfills. Mount Trashmore has been here a long time, and it's a very huge amount of trash. And everything does eventually leach. We also have a huge landfill on Cudjoe. And you mentioned that Cudjoe needed a lot of cleanup. That disturbs me because that's where I live. But I'm wondering why you are not testing the sediment of the ocean floor, because the fish that seem most affected are those who live at the bottom. And it would seem to me that you could find information in that sediment very much, maybe more valuable than the information of the water. Thank you.
Yeah, good question. So they are, I'm not really associated with the big massive study that's ongoing. This is a little minor study that we conducted really out of the seat of our pants. Honestly, we don't have funding to do this. But it's something, because I study macroalgae and I know these dinoflagellates are closely, they have these intimate relationships with these benthic plants. I thought, boy, you know, I should do something, go out there and take some samples, and I did. And we found a lot of them. But you're right, they're on the bottom, they're on the macroalgae, the wind blows, they get resuspended up into the water. We know they're in the water in high numbers. They fall down into the sediment. So they're probably everywhere out there in varying numbers. And yeah, sawfish, their gills are on the bottom, not on the side. And they eat mullet. Mullet feed off the bottom. So yes, they're everywhere probably in those areas on the bottom, whether it's seagrass or macroalgae or sediment. But they are looking at the sediment, the big FWC-led research program, okay? And so the other part of your question, yeah, the studies are not done yet, okay? As I mentioned, we've got to look at all this, the pharmaceuticals, right? That could be linked to wastewater spills or septic tanks. We need to look at the metals. There's mercury coming out of the Everglades. Goliath groupers are loaded with mercury. Does that interact with the toxins? And look at this, all these toxins that are in the water. It's I call it a cocktail, right, of toxins. It's not just one toxin. So you have all these interactions of potentially of metals, pharmaceuticals, other, as well as the toxins that can behave differently, okay, depending on the water quality, the nutrients, okay, that seem to be a key player in toxin production. So you've got all these variables. It's going to take time to sort all this out.
Dr. Lapointe, I think we're done with questions. We have one more. Okay. That's okay. I'll bet we have 1,000 more, but we're limited on the time we're allowed to be here. But if you make it quick.
I can make it quick. Hi. Thank
Hi.
you for being here. What was that thing you said about PFAS being the highest in
the-
Monroe County?
Yeah.
As opposed to all the other counties in Florida? That's very concerning to me. Thank you.
Yeah, so that paper just by Sinkman was the lead author. Sinkman, like the PFAS is coming out of your sink, right? When you wash your nonstick pans, right? Which is one source of these forever chemicals. You could Google it, okay, and probably find that paper in Science of the Total Environment. But this is a study, I think they were University of Florida researchers that took samples from all the counties in Florida, different numbers of samples in each. And they reported the highest overall average of about 79 nanograms per liter in Monroe County drinking water. And if you look on their heat map, you'll see there in southern Dade County and Monroe County, up near the well fields is very high. Up there, it's red. So again, this is something I'm sure the Aqueduct Authority is working on right now. That paper just came out. And it's interesting because EPA just reduced the standard for drinking water nationally to 4 nanograms per liter. Okay, so anyway, I'm sure you're going to be hearing more about that. You're welcome.
What kind of effect does the nuclear? Wait, you have to have the microphone. She's been trying.
I'll take it back.
I get it. Does the nuclear plant have an effect on the waters down here?
Turkey Point?
Yeah.
It's having an effect. Apparently, the hypersaline plume at Turkey Point is moving towards the well field. That's been in the news for a number of years now. I don't know what the status of that is right now. It's not there yet, but it's slowly moving. This is a hypersaline plume moving through the groundwater. But I don't think there's any evidence that it's in the drinking water supply yet or is affecting anything down here.
You referenced a swim advisory by a state agency. Can you elaborate on that a little?
Excuse me?
You referenced a swim advisory
Oh, a swim advisory.
issued by one of the state
Right.
agencies. Could you elaborate on that?
Yeah, I wasn't at, this was presented at, I think at a sanctuary advisory committee meeting, maybe a couple of weeks ago. And it was a FWC staffer who made that announcement. And I really don't know any more about it other than that was made.
Okay, then I'd like to set the record straight because that was not what was said at that meeting.
Oh, okay.
The advisory is, which is a standing advisory, if you see dead or sick fish, to not swim around them.
Right, that's right.
But there is no swim advisory for the Lower Keys as a whole.
No, but these spinning fish are pretty widespread though. So,
Okay, we're getting close to ending the meeting. I'd like to make one point of information for everybody. The report that Dr. Lapointe is referring to on the PFAS, we will have that posted tomorrow morning for everybody. You can download it. It will be on the Facebook page for the Florida Keys Environmental Coalition. If you go into your little search bar when you're in Facebook and type in fkec.org, then you'll be able to find it. We'll have it posted in the morning. Thank you, Donna.
I'm Donna Wendell. I'm the membership chair for the League of Women Voters, and we'd love to have you all understand and get to know us better. This isn't all we do. We're not a one-trick pony. We're going to be bringing you programs all year, especially this year being an election year. Everything that happens is related to what goes on politically. And certainly you're right about we can't substitute politics for science, but let's look to be voting for people who understand that. I think that's a real important thing. And we're going to be bringing you programs very frequently, so stay tuned in. I have more information over there by the door. This program has been recorded. We will send you a link to it so you can look at it or share it or whatever. And if you just sign up and put your email address, we'll get that out to you tomorrow. And thank you all so much for coming.
thank you.